Good day, students. On this clip, we're going to be going over the fundamental theorem of calculus, part 1. I'm going to present the example and the formula, and then I'll go over 2 examples, okay? All right, so let's go ahead and write down the formula for the fundamental theorem of calculus. It's basically d dx of the antiderivative from, let's say, a function, g of x as the upper bound, the integral from g of x to h of x of f of t dt equals. Now what you do here for the fundamental theorem of calculus is you basically plug in, substitute this function into f of t and then multiply by its derivative, or you compose f with this function and multiply it by the derivative of this function, just like the chain rule. So it's going to be f of g of x. You see what I just did? I basically substituted the upper bound into the function, substituted that into that, and now I'm going to multiply it by the derivative of the upper limit, which is g prime of x. Alright? And then minus, don't forget, is a minus. Now you're going to do the same thing with the lower bound, lower limits of integration. Is going to be f of, instead of t, you're going to plug in h into t, you're going to compose f with h. F of h of x, f of h of x times the derivative of the lower limit, okay, times h prime of x. Alright, so basically you substitute times the derivative of what you substituted minus lower limit, the same process. Alright, okay, let's apply this whole formula to 2 examples, and then we'll go on after that. Alright, so for examples, we're going to write, for example, following examples, these instructions, we're going to find dy dx. Okay, so for number 1, let's say we have y equals the antiderivative from 3 to x of t squared cosine t dt. Okay, so let's do it. So what we're going to do is plug in the top, substitute the top into t, and then multiply by its derivative, and then do the same with the bottom. Okay, so the y dx is going to be equal to, instead of t squared, is going to be x squared cosine x. How did I get that? I just plugged in the upper limit, which is x, into this t right here, and then into that t over there. Okay, so that's what I did. Now you get that times, we're going to multiply that times the derivative of the top. What's the derivative of x? It's just 1, right? Minus, same for the bottom, 5 squared cosine 5 times the derivative of 5, which is just 0. Okay? So this one now becomes x squared cosine x. Alright, this whole thing is 0. So remember, anytime one of the limits is a constant, that limit is gonna, you can just ignore it, because after you multiply it by its derivative, you're gonna end up with a 0 as to using the chain rule, and then that whole thing goes to 0, so that part can be ignored. Okay, so this is your final answer right here. Alright, let's try another example. Number 2, let's say we have y equals the integral from x to 5 of 1 over 2 plus e to the x. Oh, I'm sorry, e to the t, e to the t dt. Alright, so how do we do this? Same procedure, right? To substitute the top for t times its derivative and then minus the bottom. Alright, so let's do it. If I plug it, dy dx, if I substitute the top, I'm going to have 1 over 2 plus e to the 5th times the derivative of 5, which is 0. Okay? So you see how this whole piece is going to become 0 because it's a constant, minus Now plug in the bottom, 1 over 2 plus e to the x. How did I get e to the x here? By substituting x for t times the derivative of x was the derivative of x1. Alright? So your final answer is going to become negative 1 over 2 plus e to the x. Alright, so there goes your final answer. Alright, so thanks for paying attention to this presentation. I'm going to be having some more videos on some more complicated FTC Part 1 problems using the same formula. So please subscribe to my videos, and also feel free to request videos if you have any questions. Collection of my clips can be found at mathgotserved.com. Okay? Have a wonderful day.